All right, so we are writing linear equations for special lines. So we are going to write the linear equations for lines that are horizontal, vertical, parallel, and perpendicular. Horizontal lines are those lines that go straight across. They have a slope of 0 and an equation that is y equals. Vertical lines are those lines that go up and down. Their slope is undefined, and their equation is an x equals. The equations of these special lines are equal to the point with which they are crossing. So here, y is equal to b, because every y value on that line is the value of b. This is x equals c because every x value on that line is equal to c. So what that means is you have the point like c comma 1, c comma 2, c comma 3, etc. All right, perpendicular lines. Perpendicular lines are lines whose slopes are opposite reciprocals of each other. They will cross or intersect at one point and one point only. And where they intersect, that point will form a 90-degree angle. So for example, if the slope of a line was 1/2, then its opposite reciprocal would be -2. If the slope of the line was 2, its opposite reciprocal would be -1/2. Lines are parallel if their slopes are the same, but their y-intercepts are different. They have the same slope, but different y-intercepts. Bless you. You only get one. All right, write an equation of the line and graph its coordinate points and plane. So we have an equation of the line that goes through the point 5, -3, and is perpendicular to y equals 4x plus 1. So I know just reading this that my graph is going to go through the point 5, -3. It's perpendicular to 4x plus 1, which means my slope is -1/4. This plus 1 means absolutely nothing. It is part of the original equation. Because the lines are perpendicular, and the equation for perpendicular lines is the opposite reciprocal of the original. So the original slope is 4 with a y-intercept of 1. So it's graphed over here in blue. So the equation of the perpendicular line will have a slope of -1/4 and goes through the point 5, -3. So that's like my x1, y1. So in order to find the equation of the line, I have to use point slope form. So again, you can write your y-intercept as either a improper or a mixed number. So you have y equals negative 1/4 x plus 5/4, and we're going to subtract 3 from that. But because 3 and 5/4 don't have a common denominator, it's really like subtracting 12/4. So 5/4 minus 12/4 gave us a negative 7/4, which obviously isn't a very pretty y-intercept. So in order to graph the line nicely, we're just going to use our slope in our given point. So you'll plot that point 5, negative 1/3, and then you could go down 1 and right 4, or up 1 and left 4. Okay. And the next example, same idea. So we want to graph our line. We want to get the equation of our line. And we're going to use the given information. So we are given that it is perpendicular. So that means my slope is the opposite reciprocal of the equation given, going through the points given. So it's going to go through negative 1 and positive 3. My slope is going to be the opposite, so negative reciprocal 1/5. I could technically graph my line from right here because I have a point on the line and my slope. So I could go down 1 and over 5, or up 1 and left 5, but it wants the equation of the line, and you can tell or hopefully see from this that the y-intercept is not going to be a whole number, it's going to be a fraction. So we're going to use point slope form to do y minus 3 equals negative 1/5. X minus a minus turns to a positive 1. And then you get y equals negative 1/5 x minus 1/5 plus 3. And then combining like terms, you get y equals negative 1/5 x. And once again, you have to change 3 to have a common denominator with 1/5. So that would make it 15/3 minus 1/5, which would be 14 and 15/3. 15/5 minus 1/5, which would be 14/5. Okay, in the next example, we have our point, and then we're told that it's parallel. So that means the slope is the same. So my slope is 2/3 and my point is 2, 1. So that means it's going up 2 and over 3 from that point, or down 2 and left 3. So again, we should be able to notice from that graph that the y-intercept is not a nice whole number. So to get the equation of the line, we have to do point slope form from the given slope and point. So you get y minus 1 equals 2/3 x minus 2, or y minus 3/3 equals 2/3 x minus 4/3. So you add that 3/3 to the other side, and you get y equals 2/3 x minus 1/3. And again, hopefully from that graph, you can see that your point is about negative 1/3 down. No, that just says write the equation of that line and graph it. You don't have to graph the. Okay, write an equation of the line and graph its coordinate point. So again, we have 5, -3. So I know that my line is going to go through that point. This line is vertical. So a vertical line has a slope undefined. And my equation is always x equals. And it's x equals the x coordinate I'm given. So in this case, the equation of the line is x equals 5. And what that means is that any point on this line is true as long as the x value is 5. And then similarly, a horizontal line will be straight across. The slope of a horizontal line is 0 because all points on the horizontal line are changing on x, but not on y. So this goes through the point -2, 2. And that means any line on there will go through a y value of 2. So you could pick any point on there to find that that slope is 0. So if this is my x1, y1, I could say x2 and y2 are the points 2, 2. And what you would see is if you calculated your slope, you'd get 2 minus 2 over 2 minus a minus 2, which gives you 0 over 4, which is 0. So you can always check that that slope is 0. The equation of a horizontal line is always y equals. So in this case, it would be y equals 2, because every point on that line will have a y value of 2. Okay, so again, every graph we've looked at today is considered a line. Now, it is important to talk about the last two graphs. The domain of that last graph is all reals. However, the range in this case is unique. The range is simply y equals 2. And on the previous graph, it would have been very similar. However, now the domain would have been x equals 5, and my range was all reals. So again, those two are just a little bit unique. They're unique in their equations as well as their domain and range. So we're going to use the remainder of class time to do the front and back of the next page in your packet. So it's technically page 87 from the book, 27 to 26, or 23 to 26, and then the 27 to 35 are problems I've created to give you that extra practice.